All right, so we're going to go over some of the midterm review questions. That way you got a little video in case you want to watch the video instead of just looking at the document that I posted. So we'll start with question one. So question one states if hn is 11, so we know hn is given to be 11, we have to find the value of x. We got a couple x's in the problem, but since we have a line segment, we're probably going to end up using segment addition. So I know I want to do segment addition. So segment addition says if I add up the two small pieces, I should get the big piece. So that means if I add up FH, that's one of the small pieces, plus HN, I should end up with the whole line segment. So I should end up with FN. Okay, so down here, FH we're told is 3x plus 7. So we're going to do substitution and just say FH is 3x plus 7. HN we're told is 11. So we'll add 11. And then Fn, they actually gave us Fn also. So Fn, they tell us over here, is 12x minus 9. So what this ends up being is this ends up being an algebra problem, all the way back from Unit 1. So we'll combine our like terms. So we got 7 and 11, so that's going to become 18. I'm going to leave everything else the same. So I combine those two like terms. I'm going to do these ones all algebra style, just because it's a couple more steps to show out. So I got to get the x by itself, so I'm going to subtract 3x on both sides. So I get 18 equals 9x minus 9. I have to add 9 to both sides. So I get 27 equals 9x. And then at the very end, I have to get the x by itself, so I have to divide both sides by 9. So I get 3 equals x. So I'm going to go back and double check to make sure that's what I wanted to do. It says, what's the value of x? We found x was 3. So remember, sometimes the question won't ask for x. Sometimes the question will ask for fh or fn. But in this case, they just wanted to know what x was, so we say it's 3. All right, for number 2, it says mark one set of corresponding angles in the image. So it only tells us that I have to do one. So I have to remember what the definition for corresponding angles are. Since we've got these two are marked as parallel, we could tell because they've got these lines right here. If not, we're going to call those two parallel. We only need one set of corresponding. So corresponding is ones that are in the same spot. So I can pick one. And if I think of this as like an intersection, the one is kind of like, going the other way, but the one is in the upper left. So the one over here at this intersection that's in the upper left is number 5. So I can mark those. That's angles 1 and 5. Because for part B, it says choose possible measures for those angles and put them in the table. Well, 1 and 5, they look like they're less than 90 degrees. So I can pick whatever I want as long as it's less than 90 degrees. I think 60 seems like a good number. Again, you can pick whatever you want. Since they do look like they're acute, you should pick something that's less than a right angle, less than 90. Now, that's not the only answer for this one. Since you just had to pick any set of corresponding angles, if I wanted to pick 4 and 8, I could pick 4 and 8. And those are both going to be acute also. So we can also say that those are both 60. Again, you have to pick both the green angles, though. You can't pick any of the red ones. That's not the only choices you can make. You can also say 2 and 6. Those are both corresponding. If I wanted to fill out the table that way, I might say that they're both 120 degrees. Or, I mean, I got one more choice. I could say 3 and 7. And I'd probably say that those are 120 degrees or thereabouts for those choices also. So you got 4 different options for your choices for corresponding, and you have freedom to choose the correct, not the correct, but the values that you want for the angles. So that's question 2. Question 3, distance formula. So it's just a straight application of the distance formula. So you have to remember the distance formula. So distance formula is d equals square root of x2 minus x1 squared plus y2 minus y1 squared. So if we look up here, we can label these x1, y1, x2, y2. And we're just going to plop them right into the distance formula. Give myself a little bit of extra space. Because distance formula is a little bit big. So d equals the square root of, I know I'm going to have to put some things in and square them. I'm going to have to put some more things in and square them. So let's plug them in. So x2 is a 1. And y2 is a -5. x1 is 7. And y1 is -2. So we have to be a little bit careful because there is a double negative there for the red one right here. So when we simplify it, we get d equals the square root. 1 minus 7 is -6 squared. So we got to do a parentheses first. -5 minus -2 is like -5 plus 2, so -3 squared. So that's like the square root of 36 plus 9, which is the square root of 45. Now this question wants to know what it is to the nearest hundredth, so I do have to put that into a calculator. I don't know exactly what the square root of 45 is, so off the top of my head, I know it's going to be between 6 and 7. So I'll use my calculator, I'll plug it into the calculator. So we do the square root of 45, and we get 6.708. 708, but to the nearest hundredth, remember hundredth is 2 decimal places, so I'm going to round this up to 6.71. So that's what it is to the nearest hundredth. All right. For the fourth one, it says use the image to complete the table. If we look on this x, y, z, those points are all on the same line. So right away, I know that this is going to create a linear pair. I know from our theorems that a linear pair has to add up to 180 degrees. So I know that angle x, y, q, so that's this one, plus zyq has to equal 180 degrees. So that's good because those are the two that we have to find. So hopefully we'll be able to find them pretty quickly since we know that they add up to 180. So xyq is that one, and that's the 2x minus 5. So, sorry, 20x minus 5, more than 2x. So 20x minus 5. Zyq is the smaller one over here. So that's 4x plus 5. We still know that that equals 180. And now again from here, kind of like some of the other ones, it's an algebra one. So a lot of stuff we did early on had to deal with a little bit of extra algebra. So combine our like terms, 20x plus 4x is 24x. Minus 5 plus 5 is 0. I'll still put the 0 there. We know that we don't really need to if we don't want to. And then to get x by itself, we have to divide by 24. So we'll divide both sides by 24. So x equals, I'm going to double check. I think that's like 7.5, but I'm going to double check in case I forgot it. Oh, yep, that works. So I put it in the calculator. I got x is 7.5. Now in this case, the question didn't ask for x. We're trying to complete the chart, so we got to find out these two angles. So the blue angle is 20x minus 5. So to get this one, I have to do 20 times 7.5 and then minus 5. Again, I'm just going to be really careful today, and I'm going to plug that into the calculator also. 20 times 7.5 minus 5, I get 145. So I know that this angle is 145 degrees. Now for the red one, I could plug it back into this 4x plus 5 if I wanted to, but I also know that they have to add up to 180. So I could also just say 180 minus 145 is going to be 35. And that's a little bit easier for the math for me to do. That way I don't need the calculator. If I wanted to, I could double check. I could plug it in. 4 times 7.5 plus 5, which is 30 plus 5, which is 35. So I do check out. It works either way you do it. That's a good way you can double check to make sure that you got the right numbers, is if that does check out correctly. All right, number 5 says use the graph on the left. We need to draw a line CD parallel to AB and through point X. What is the slope of CD? So there's a lot that's going on. So the first thing we want to do is let's actually answer this question first. Because we know if things that are parallel, they have the same slope. So if I can figure out the slope of AB, then I know what the slope of CD is because they have to be the same. So let's count. We got 1, 2, 3, 4. So we're going to rise 4. And we're going to run 2. You know, slope is rise over run. So if we're going to rise 4 and run 2, we're going to end up at 2. So we got 2 as the slope for CD. So now that I know 2 is the slope for CD, that means I can now draw a line CD from point X, because I know my slope is 2. So from point X, I'll go up 2 over 1, up 2 over 1. I can also go down 2, back 1 if I want, down 2, back 1. And I can make a nice line. Oops. There's my line tool. So I want to remind myself that that is CD. So I'll put C right there, and let's put D down there somewhere. So I got CD in the picture. And I know that these two lines are parallel because they have the same slope. So the second part of this question says, let the measure of APY, so that's this angle right here, be Q degrees. Mark each angle with vertex X equal to 180 minus Q. Well, I know the ones that are equal to 180 minus Q are the ones that make a linear pair with APY. So if I think about it, this one and this one are both 180 minus Q because they make a linear pair with APY. So that's what I chose to do at first, is I made a linear pair with angle APY. And that gave me these two angles right here. Now, I don't have names for those. I guess this one I could call it XAB, but I don't really have good names for those. So I'm just going to mark them because it just says to mark them in the picture. So that makes those 180 minus Q. Now, those don't have vertex X, though. Those have vertex P. So somehow I need to get over here. But we can do that because we know our rules for parallel lines. And we can actually do alternate interior angles if we wanted to mark that up. So we know that this XPA, this one's going to be alternate interior with the one I just marked. I could also say I have alternate exterior. So down here, this one over here would be alternate exterior with this one over here. So I can mark that, and that's one way that we can think about it, and we're done. We don't need to name them, we just had to mark them. There's a lot of other ways that you could have got there. You could have did some corresponding angles, since we did corresponding angles in one of the previous questions. Once you got one of the two up there, you could say that they were vertical, because the vertical angles have to be equal, and so we know that those are all also the same. So we've answered what we needed to, so we're going to move on. Question 6, we need to get the equation of a line perpendicular to y equals negative 3/2 x minus 7. It has to pass through 1, 4. All right, well, we did the parallel slope. Parallel slopes are the same. If I want the perpendicular slope, this is where we have to take the opposite reciprocal. So flip the fraction, switch the sign. So if I find the slope that we're given is negative 3 over 2. So since m is negative 3 over 2, if I want, I could throw it into this formula. It looks a little bit complicated, but when you know you're dealing with fractions, we end up with 2/3. And that's the same thing you get as if you took the negative 3/2, you flipped it, so you got 2 over 3, and you switched it from negative to positive. So you can think about it as the little mnemonic trick, or you can actually throw it in the formula and calculate it that way. But we know what the slope now is. So that's good. But we need the line that not just has a slope, but also passes through 1, 4. So to do that, we're going to need to use point slope form. And so this is all the way back from the kind of the beginning of the first unit. So we're going to have to do our point slope form, and that's y minus y1 equals mx minus x1. Okay, so since we're trying to get the slope perpendicular, we do know the slope. So I'm going to underline that one in blue. We need that to be 2/3. Remember in this formula, the x and the y, they don't change. So that stays the same. That x is going to stay the same. X1 and Y1, though, we get from the point over here. So Y1 is 1. Sorry, Y1's 4. Y1's not 1. X1 is 1. And that's actually it. That's our entire equation. So we can go ahead and just throw that into the answer choice. So y minus 4 equals 2/3 x minus 1. And that's it. That's our equation of the line that is perpendicular and passes through. You don't need to simplify it if you don't want to. You don't need to turn it into y equals mx plus b form. You can leave it in point slope form. That's okay. All right, for number 7, looks like we have a triangle. We have to find a couple things. So let's complete the table using the image to the right. We have to find x and then each of the angles. Well, that's not too bad because, again, we do have a triangle. And so we know we do have our triangle sum theorem. So our triangle sum theorem states that all the angles have to add up to 180. So I can go ahead and just write out each of the angles. So that's 2x plus 20 plus 3x plus x plus 10 is equal to 180. So I did A, then B, then C. So again, here we got a little bit of algebra. We can combine all the x's as like terms. So that gives us 6x. We can combine 20 and 10 as like terms. So we get 30. Some more algebra. Subtract 30 from both sides. 6x equals 150. We can divide both sides by 6. And x equals 25. 25 quarters, or sorry, 6 quarters would be $1.50. That's an easy one to do. All right, so we know x is 25. So we got that part done. So the next thing we have to do is get all the angles. So we have to get angle A, angle B, and then angle C. So if we look, angle A right here is 2x plus 20. So if we plug that in, 2 times 25 plus 20, we get 50 plus 20 is 70. So we know that one's 70 degrees. Put our little degree signs in. B down here is 3x. So 3 times 25 is just 75. So we get 75 degrees. And for the last one, if you want, you could do 180 minus that sum. I think this one is actually going to be easier if we just plug it in and say 25 plus 10 is 35. And so that's what angle C is going to be, is 35 degrees. So we find out that, remember, triangle equals 180, and we get some substitution from there. All right, number 8 says which rigid motion maps this. This triangle doesn't look like it's rotated, so I'm not going to pick rotation. The triangle doesn't really look like we flip it. We're not really reflecting it, so I'm not going to pick that one. So I think I'm going to go with translation. So it looks like we just kind of move that triangle from one place to the next. There's a second part to this question that asks you to put in the transformation. So for a translation, we just have to say, well, we're going to start there, and we're just going to move it. So we just have to draw a nice little translation arrow. All we need is one, because the whole shape goes along that same arrow. If you remember when we did Desmos Golf, you just needed to have one arrow. It didn't really matter where it was. You just need to have that arrow to go from the start to the finish. So I could pick that one if I wanted to. I could pick this one, or I could pick this one. As long as your arrows just go from start to finish. If I really wanted to, I could even draw the arrow somewhere else. I'd have to be really careful that way, though. For rotation, remember, you'd probably want to do a point of rotation and then a number of degrees. For reflection, you want to draw on your line of reflection would be what you'd want to do. So that's what the two other options are, because the question does change depending on which one you pick. So depending on which one you pick, it asks you to do that to the figure in the picture. All right, number 9, we have this quadrilateral. It's glide reflected along the y-axis and a translation of 1, 2 to make A prime, B prime, C prime, D prime. Select each of the true statements. It's known that DC is parallel to AB. So that means you don't need to double check the slopes. You don't need to count the slopes just to double check that. They're telling you that is true. Don't bother checking it. It's true. So One thing we could do is we could glide reflect the whole thing, but we also know that a glide reflection, that's a rigid motion. That's one of our 4 rigid motions. And for our definitions for rigid motions, we have to have all the angles stay the same, and all the sides also have to be congruent. So remember, the shape doesn't change and the size doesn't change. That's always true for rigid motions. You can think of them like translation, you don't change the size or the shape. Same deal with the glide reflection. So if we're going to make one angle suddenly become bigger than what the ending angle is going to be, that doesn't really make much sense. We can't have our one angle be bigger than our second. So we're going to get rid of that one. We can have both of them still be parallel. So DC and AB and DC, that works out because the angles have to be the same. So if 2 things are parallel at the beginning, they got to be parallel at the end. So we are going to pick that one. And then CD is equal to C prime D prime. Well, that's the sides are congruent, so that's got to be the same because our new shape has to have the exact same sides. And there we go. That's all we got to do. So we're done with question 9. If you want, you do have some space to draw out the picture. So if you wanted to draw it out, you could. So y-axis we would reflect along here. And then we'd have to move 1 to the right and 2 up. So 1 to the right, 2 up. B prime ends there. 5, 6, 7. So 5, 6, 7. Then we go 1 to the right and 2 up. A prime will go there. C, that's right at 5. So we go 1 to the right, 2 up. C prime will end up there. And D's at 8. That's pretty far. But we go 1 to the right and 2 up. And so if you did want to draw the second glide reflected figure, we can see that these 2 are still going to be the same since they're parallel in the initial. We can also see C prime D prime is also the same. 1, 4, 1, 4. So, or sorry, 1, 3. 1, 2, 3, yeah. 1, 3, 1, 3. So that doesn't change either. That's still going to have the length of the square root of 10 if we were to plug it into the distance formula. So if you do want to double check, you can draw it and you can see what it looks like. And you can double check those. You can see that these angles are also the same, ABC and the other A prime, B prime, C prime. Those angles are both going to be the same. So we don't want to pick the first one still. All right. Question 10 says to draw any lines of symmetry in each of the letters. If we look at the Y, it looks like we could split it right down the middle this way. So there's my line of symmetry. For the C, it looks like we could split it down the middle this way. That's my line of symmetry. For the H, we could split it right down the middle. Either way, so that one's got 2 lines of symmetry. So that's 2 options. And J doesn't really have any. It doesn't look like we can split that any which way. So that one has no line of symmetry. So we could just leave that one alone if we wanted to. All right, so for number 11, we're told the rule R over y equals -2 is applied to the point 3, 1. Which part of the coordinate system is the translated point located? Which this is not a translated point. This is a reflected point. So we'll go ahead and switch that. So what we're going to do is try and draw it out. So let's see what happens. So I can make a nice little sketch of a coordinate grid. And I know my point's at 3, 1. So I'll go 1, 2, 3 over, 1 up. So I'll put my point there. So that's where my original point is. And my rule says I'm going to reflect along y equals -2. So I'm going to go down 2 and draw in a line of reflection. So remember, reflection means we're going to flip it. So in this case, looks like to get to the line of reflection, 1, 2, 3, it's going to take us 3 to get to the line of reflection. So if we wanted to reflect it, we'd have to go another 3 down. 1, 2, 3. So that's where my point is going to end up. And then we just have to decide what quadrant that's in. So remember the quadrants. Quadrant 1 is up here. Quadrant 2, quadrant 3, and then quadrant 4. So that one ended up in quadrant 4. We did big quadrant 4. So that's where that one ended up. So we just wanted to follow the point along the transformation. For 12, which triangle is congruent to JKL? Well, let's check. So JKL, remember, if something is congruent, it's got to have the same shape and the same size. So if we checked from J to K, we've got 2 and 4. So something else is going to have that same 2 and 4 if it's going to be the same shape and the same size as JKL. So same shape would mean we need a 2 and a 4. Same size means we just need kind of that slope of 1/2. So let's check. We got DEF. So that'll be the first one we check out. If we look, we've got 1 and 2. So it's got the same shape, but not the same size. But maybe one of the other ones works out. We've got 1 and 3. Well, that's neither, so that doesn't help us. We got 3 and 2. So we don't have anything that matches with the 2 and 4. So we have no 2 and 4 match. So we know it can't be that one. That one's out. PQR is next. So let's check. So again, we got 1 and 2, so that's good, but not good enough because we need to have 2 and 4. So we've got 2 and 3, that doesn't work. We've got 3 and 1, so that doesn't work either. All right, well, the good news is we're down to one option. So it's either STU or it's none of them. So let's check. We've got 1, 2, 3, 4, 1, 2. Okay, so that does work out. So far that one's looking good. Again, I can't pick that one right away. I got to make sure that all the sides are the same, but at least I know that I've got at least one match. So I'm not going to cross it off right away. So I'm going to move on. I'm going to try another one out. So I'm going to go from K to L next. So I can go down 3 and over 1. So 3 and 1. Well, these ones both had 3 and 1, but they were already out, so we don't really have to worry about those ones. The only one I'm concerned about is SUT. So we got to go 2 and 2. Well, that doesn't match, but that's okay. I might have just picked the wrong side. We still could just be the last side. So if we do the last side, we're going to go 2 down and 1, 2, 3, 4. We got another 2 and 4, so nothing matched up with the 3 and 1. So we didn't match up with that 3 and 1 side. So it can't be STU. Because all the sides are not the same. So we at least have a few different sides. So we're out. That's it. So the answer has to be none of the above because none of the other triangles matched up. So that's one we're going to pick. So again, remember this one deals with congruent. It has to be the same size. So same slope. I guess that would be for the same shape. And the same size. And that would be the length. Again, if you wanted to, you could plug 2 and 4 into the distance formula. That give you the square root of 20. And the purple one's the only one that has the side with the square root of 20. If we plug 3 and 1 into the distance formula, we get square root of 10. And the purple one does not have a square root of 10 length. So it's out. That's the end of that one. For 13, it says, given DCE is 30, find all missing angle measures. So DCE is 30. So we're going to label that one because it's given. And right away I know that this one is 30 because those two angles are vertical. So wherever this one is in the chart, we're going to make that one 30 degrees. So BCA, that's this one right here. So this one's 30 degrees. And we know that because it's vertical. We really didn't have to do much to get that one. Then if I look, it looks like I've got an isosceles triangle here because I've got two sides that are the same. So DC and DE are the same because they're labeled with the two tick marks. So we know that that's an isosceles triangle. So CDE is isosceles. So that means that the angles across from the sides that are the same are also the same. So since DE is across from this 30, CD also has to be across from a 30. So I can find this one in the chart. So CED, so E is in the middle, so I want the one E in the middle, which is right there. So that's 30 degrees. So we know that because it's isosceles. But we also know that the triangle has to add up to 180. So if I make this one X, I could say, well, this triangle has to add up to 180. So 180 equals X plus 30 plus 30. So again, triangle has to equal 180. 180 equals X plus 60 if we combine the like terms. If we subtract 60 from both sides, we get 120 for X. D is the vertex, so D's got to be in the middle here. So we can figure that one out just because we know that triangles have to add up to 180. All right, we got two more to figure out. But again, if we look, this is another isosceles triangle because they're marked with one tick mark. So these two angles have to be the same. So A and B have to be the same. I don't know what they are, so I'm going to call them Y because we already used X. But I do know that they have to be the same. So that's good that these two are just going to be the same number. And I'm going to use the same triangle equals 180 idea and say that 180 is equal to 30 plus Y plus another Y. This time when we combine like terms, we get 2Y. So we're going to have one extra algebra step. Again, subtract 30 from both sides. Then divide both sides by 2 to get 75 equals Y. Well, since Y is both of these angles, both of these are 75 degrees. So we can label those both as 75 degrees, and we found all the missing angle measures. So you want to be careful and look and see which angles are actually the same in the picture. So it's probably not a good idea just to memorize, oh, look at these two, they have to be the same. That would be a bad idea. You need to actually use geometry to figure them out and say, well, two angles, the angles across from the ones that are marked 2 have to be the same. The angles that are across one that's marked 1, that'll be the same too, since some of you did that on the last test. All right, for 14, we know that these two triangles are congruent. Find the values in the chart below. Well, since these two triangles are congruent, we know by CP/CTC that the corresponding parts of congruent triangles are congruent. So that means that I know, because we were told that they were congruent, AB, two letters on the ends, have to be the same as CD. And that's good because it looks like that should be true in the picture, but it's only true because of CP/CTC. If we weren't told that these two things were congruent, we couldn't actually state that these were the same. So let's solve this because we can actually solve for Z at this point because we know that those two are the same. So we'll set those two expressions equal. 7Z plus 8 equals 4Z plus 32. So we can subtract 4Z from both sides. So we get 3Z plus 8 equals 32. Subtract 8 again from both sides. So 3Z equals 24. Divide by 3 to get Z equals 8. All right, well, we got Z. We didn't get them in order, but that's okay. We don't need to get them in order. But again, from CP/CTC, if we go back up to our two triangles, if I want to find AD, AD is the first two letters. That's the same as CB. So CB is right here. So I can actually set these two expressions equal to each other. So 6y plus 5 is equal to 4y plus 14. So again, looks like we got a little bit of algebra, but this will get us y. So it looks like we're solving backwards. That's okay. We can solve backwards. Minus 4y on both sides. So we get 2y plus 5 equals 14. Subtract 5 from both sides. My picture's in the way. That's all right. 2y equals 9. Divide both sides by 2. So we get y is 4.5. So we'll put that up here, 4.5. All right, well, the last one we want to get is we want to get x. It looks like x is kind of in between here. It looks like it's going to be these two angles. So hopefully those two are the same. So it looks like we got angle A. Well, A is first. Angle C. C is first. So again, by CP/CTC, angle A is congruent to angle C. So we know that those two angles have to have the same value. So that means, again, we can go ahead and solve. 3x minus 40 has to be equal to 2x plus 12. Same algebra again. We're just going to try to get the x by itself. Subtract 2x from both sides. Oops. Add 40 to both sides. So we get x equals 52. Okay. So x is 52. And that's it. So this one just wanted us to find x, y, and z. I'm going to put the 52 right there. And we were done. So again, this one just asked for the variables. It didn't ask us to find the sides, which it could do. Didn't ask us to find the angles, which it could do. This one we just wanted to find out what x, y, and z were, so we did. So I guess we're done with this one. All right. For 15, it says draw one extra piece of information in the image to create congruent triangles. List the congruence condition listed. Well, I see I got right triangles, so my favorite one to do is HL for right triangles. Since I've given a leg in both of them, I need the hypotenuse. So I'm going to mark it and say I've got HL. And that's going to be about it. That's all we had to do. Now there's a lot of different options. So just like one of them that was where we had to mark our corresponding angles, there's a lot of different choices that we could do. If I wanted to, I could mark instead these two sides, but I couldn't say HL anymore. I'd have to say that we had SAS, because we'd have two sides and the angle between them. So if I wanted, I could do that. But if I wanted, I could do something else. I could say, hey, wait, these two are the same. What if these two were? Well, if these two were the same, then I'd have an angle, another angle in the side between them. So in that case, I'd have ASA congruence. Okay, well, what if I wanted to go all the way over here? Well, if I mark those ones, then I'd have an angle, another angle on the side outside of it. So I'd have AS congruence. So that's another option. So it's pretty crazy because it turns out we could have kind of 4 of the 5 congruency conditions depending on which one we actually chose. So again, the point here is you need to be able to choose the right one that goes along with what the information is presented. So we talked about them as puzzles. So it's trying to say, hey, if you choose the right piece, you have to find out where it actually connects in the triangles as a whole. In this case, the only one we couldn't use, we could not do SSS because we don't have 3. We can't draw 2 extra pieces of information. We'd have to have both the blue and the purple to do SSS. So we couldn't do that one with just 1 extra piece. So that's how that one goes. For 16, state the congruent triangles and the congruence condition that proves that they are congruent. So the nice thing is we got some vertical angles here. Oops. So this comes out to be pretty nice because we know those are vertical. So since they're vertical, if we follow it along, we can start at the 1 and go past the 2 to get triangle TUS. And we can start at the 1 and go past the 2 to get WUV. And that's one of our options. To do this one, we did ASA because the side's between them. So we had ASA congruence. This is another one where there's a lot of different options for things that are correct for the triangles. Only ASA would be okay for the reason. So you're kind of stuck with the reason of ASA. But again, depending on where you started and how you went around the triangle, you could have one of 6 options. This is the first one. If we wanted to go backwards from what I did, we could say TSU is congruent to triangle WVU. That would be okay. So again, we're making sure everything matches up in both triangles. And in this case, they do. If I wanted to start at U, I could start at U. So UST if I wanted to go this way. So I'm following the same order, so UVW. And if I wanted to go the other direction, UTS, UVW. Oops, sorry, UWV. Go in the opposite direction. Or if I wanted to start at S, if I go the same direction, STU, VWU, or if I wanted to go backwards from the arrows, SUT, and VUW. So again, if we look, all the U's are in the same spot. So middle and middle matches up, end matches up, end, middle. T and W always match up. So here they're first, last, middle, last, and then by virtue of being the only one left, the S and the V always have to match up. So as long as those are in the corresponding places, then you know you've got your triangles correct. So any one of these other 5 options would also be okay for that one. But you do need ASA. That's kind of the only one that we can pick for this one. For 17, we're told that y is 21, so we have to find the values listed in the table. So if y is 21, well, we kind of know that 2y is 42. So we know this is 42, and this actually creates a unique situation. And this is one of our theorems that we had. I think that's theorem 4.2 if I remember correctly. But one of our theorems states, if we have a perpendicular bisector, then our triangle is isosceles. So it turns out, because these two angles are the same, because we have 90-degree angles, and because our two sides are the same, we do end up with an isosceles triangle. So since AD is a perpendicular bisector, triangle CAB is isosceles. So that means that these two sides have to be the same. These two angles are the same. I don't think we're going to use those angles at all, but we do know that those angles are the same. So I think that's going to give us all the tools that we need to solve this one. Now, if I look in my chart, angle CAB is one thing that I have to find. I may as well do that first, since that's going to be just some angle addition. I'm just going to add these two angles up to get the whole angle. So 42 plus 42 is going to be 84. So I may as well just solve for that one right away, since that's angle addition. So the next ones I got to get is I got to get x and then the two sides. Well, it looks like I have to get x in order to get the sides, so I'm going to get x first. Nice thing is, since this triangle is isosceles, we know that these two expressions have to be the same. They have to be equal. So we can just set them equal to each other. So let's say state what we need to. So we do have an isosceles. So AC is equal to AB in this case. So now AC is 7x minus 3. AB is 4x plus 18. So subtracting 4x on both sides, that's going to give us 3x minus 3 equals 18. We can add 3 to both sides. So 3x is 21. Divide both sides by 3 to get x equals 7. Well, this is good because x was one of the things we had to get in the chart. So we can go ahead and just plug a 7 in for our value. So if I want to find out AC, now that I know what x is, now that I know that x is 7, I can actually just plug 7 in for the x. So I'm going to plug 7 in for x. So this is 49 minus 3 is 46. So I know AC is 46. Now, again, just like we had in that other question, if I wanted to, I could plug 7 in for this one over here. But I know AC and AB have to be the same because they're isosceles. So I know this one's automatically going to be 46. Again, I can double check it if I want. So 4 times 7 plus 18, 28 plus 18 is 46. So those check out. So again, it's good to check so we can double check to make sure we got the right result. And we did. So that worked out. So we've got all of our values in the chart. So it looks like we're all set with our triangle. All right, for number 18, it says use the figure on the left to find the value of x. So it looks like we've got a nice polygon. It looks like it's got 7 sides. So we know we have 7 sides. It's a polygon. So that means we can say that the total interior angles is going to follow our total interior angle formula. N minus 2 times 180. Well, in this case, since we have 7 sides, n is going to be 7. So this is going to be equal to, we can just go ahead and say 7 minus 2 times 180, which is 5 times 180, which is 900. So we know that's what we would get if we added them all up. So we have to add them all up. So we're going to take each of our angles, we're going to add up each of our angles. And again, if we want to double check that we had 7 sides, we could say we got 1, 2, 3, 4, 5, 6, 7 angles. So our total interior angles is also going to be, if I added all these up, x plus 125 plus 120 plus 140 plus 145 plus 110 plus 163. 1, 2, 3, 4, 5, 6, 7. Okay, sounds good. Now we know the total interior angles is 900. So I know that 900 is equal to x plus, and now I have to combine all these like terms. So I got to add all those up. So again, I got the calculator. I may as well throw them into the calculator. There we go. I get 803. So we get 803. To get x by itself, actually all we got to do is subtract 803. All right, so there's our minus 803. We can subtract 803 over here, and that's going to give us our final value for x. So we get 97 for x. And that's exactly what we wanted to do, was we wanted to find x. So we got it. So x is 97 degrees. Pretty good. All right. So one more question that deals with some of that same idea. In this case, so we have a 74gon, so we have a really big polygon now. It says complete to the nearest tenth of a degree the chart below. So the first one, again, we've got the total interior angle measures. This is the same formula as the last one. So that one's actually going to be pretty nice because this is just going to be the same 180 times n minus 2 formula. In this case, we got a big number though. We have 74 is our n. So 180 times 74 minus 2 is going to be 180 times 72. And again, that's going to be something that we're just going to throw into the calculator at this point. So 180 times 72 is 12,960. It's a lot of degrees. That's fine. It's a big shape. It can have a lot of degrees. Next one says we have to find the measure of one interior angle. Well, if we're just finding one of them and we know what the total is, if I divided by 74, I'd get the value of one of them. So what we're going to do, let me finish this equals up though. What we're going to do is we're going to take this value that we got and we're going to divide it by 74. The formula for that would be 180 times n minus 2. Should be doing that in green, so we'll flip that. So we don't get our formulas mixed up. 180 times n minus 2, all divided by n. I'm still going to substitute in red though. We know 180 times n minus 2 because that's what we found for the total interior angle measures. So that's 12960. N is still 74. We still have 74 sides. So if I divide by 74, I get 175.1. It just says I have to go to the nearest tenth, so I only need one decimal place. You can go more if you want, but it only asked for one. The total exterior angle measures. Well, it's got its own. So this is one of our theorems, and it says that it's always just going to be 360 degrees. So we know that one is just straight up 360. We don't have to do anything. Total exterior is always 360 for a polygon. Lastly, we've got the measure of one exterior angle. So just like we did in green, all we have to do is divide by n, divide by 74, and that'll give us our value. So 360 over n, if we sub in 360 over 74, and that's 4.9. We go to one decimal place. Now, if I wanted to double check to make sure that I did it right, I can. I have another check here. Because an exterior angle and an interior angle, those should add up to 180 because they should make a linear pair. That's where we came up with the formula. So if I wanted to double check, 175.1 plus 4.9 does equal 180, so that checks out. So that tells me that I did get the right answer. So again, this one's got another built-in check that you could do. All right, for 20, we've got a lot of things. This is a big chart. So we're told that this thing is an isosceles trapezoid, so complete the chart below. So we have to find out what AD is the same as, what it's congruent to. So since it's an isosceles trapezoid, we know that AD and BC are automatically the same. Because for an isosceles trapezoid, that's one of the given pieces. In an isosceles trapezoid, we also know that these two angles are the same. So I'm going to see if that's in my chart somewhere. So DAB or BAD, and not quite. This one's pretty close. ABC, ABC is right there. So ABC is the same as BAD. The other thing we know in an isosceles trapezoid is we're also given an isosceles trapezoid that those two angles have to be the same. So let's see if there's something with a D or a C in the middle. Over here, BDC, not quite. ABD, not quite. So they didn't give us that one, even though we do know that. The last piece of information that we know, since we were given it's an isosceles trapezoid, is we know the diagonals have to be the same. So if AC and BD are somewhere, there's AC, so that has to match with BD. So that's pretty nice. Those are all the things that we're just kind of given if we know that things are isosceles. If we have an isosceles trapezoid. So I'm going to erase all those ones because we've kind of gotten everything we know just from it being an isosceles trapezoid. So the other cool thing is with the isosceles trapezoid, remember we did all of the triangles in class. So we do know that this is an isosceles triangle. So AQB is isosceles. So since we know that, we also again know AQ and BQ are the same. So here we got AQ, so we can say AQ and BQ are equal. Those two are congruent. And then we also know that the two angles over here are also going to be the same. So if I've got a BAC or an ABD, that'll help out. I do have an ABD, so ABD is the same as BAC. Again, I'm not going to go through the whole triangle proof, but it deals with the fact that in a trapezoid, remember that these two are parallel, so you can get some alternate interior angles and it will all work out. So we got that figured out, so that's pretty good. So I'm going to erase this one because we got kind of everything that we could get from our isosceles triangle here. But remember, the cool thing is it makes also an isosceles triangle on the bottom. So triangle DQC is also an isosceles triangle, which means these two sides are the same, and those two angles are the same. So DQ and QC have to be the same. I see a DQ, so I know it's the same as QC. And do I have QDC? I got an AQB. Nah, that's not that one though. So that's everything that it looks like it was given to us in that case. So we got to get rid of those. We'll get rid of those and we'll see what we got left in our chart. Well, one of them that we have in the chart is we've got AQB. So if I look at that angle, that one's got to be the same as this one because those two are vertical. So that one's a little bit unique. We didn't have to use the isosceles trapezoid at all. We just know that those two are vertical. So DQC would work out for that one. Because again, these two angles are going to be vertical. So that just leaves one last piece. So there's one more to go. We'll go blue again. And that's BDC. So if I draw this one in, this angle actually matches up with one that we had in one of our other isosceles triangles. So that angle, believe it or not, that's going to match up right here with QCD. Now I could go all the way out to A if I wanted to. And I think I'm going to just to make it seem a little bit more normal, just to make those look exactly the same. So we know that ACD and BDC are the same. So we'll say ACD. That's not a D, that was a Q. And again, we know that because we had that one isosceles triangle. down here. So remember DQC was isosceles, so that's why we know those two angles have to be the same. That's a big chart, but that's everything that we know. So the cool thing is there's no algebra involved in that one. That's just a straight geometry one. That's pretty fun. All right, so the next couple questions are actually from things that, I don't know if we've done these ones yet, because I think we got some parallelograms coming up. But we've got parallelogram DEFG, so we want to stay on our toes for the parallelogram. So in parallelograms, what we're given is EX is 2x, and XG is 3x minus 5. So in a parallelogram, one of the 5 parallelogram properties, which we did this one actually, because now I remember we were kind of bummed out that we didn't get to spin for all the parallelogram properties. But for our parallelogram properties, we know that the diagonals bisect each other. So in parallelogram, diagonals bisect each other. So that means that in this case, EX has to be the same as XG. All right, so we know that from basically just all the given information. So it looks like DF is going to have something involving X. So I think I'm just going to find out what X is right away. So EX over here, like we can see, EX is 2X. XG is 3X minus 5. All right, so we got another one to solve. I'm going to subtract 3x from both sides, then divide by -1 to get x equals 5. Okay, so df up here it says is 2x minus 1. So that's this whole length. Well, if I plug 5 in for x, I get 9. So I know this whole length is 9. I need to find dx. Well, dx goes to the midpoint, but because the diagonals bisect each other, that means that dx has to be half of df. But we found df. df was 9. So this is going to be a half times 9, or 4.5. And so that's all we're going to do right there. That's pretty cool. So that's an interesting application for our parallelogram property. All right. 22 says we have to do some more parallelogram stuff. Fill in the chart with values that would make ABCD a parallelogram. So another parallelogram property that we have is we know that in a parallelogram, the sides are congruent. So if I want this thing to be a parallelogram, I got to make sure that my two sides are going to be the same. Just opposite sides are congruent. I don't want those ones. So I know that BC and AD have to be the same. So this is pretty convenient because we got to find BC and AD. So once I found one, I know what the other one is because they have to be the same. And kind of like the last one, we can just kind of plug in. We've got 2x plus 4 for BC. We got 3x minus 3 for AD. Same deal. We're trying to get the x by itself, so we'll do a little bit of algebra. So x minus 3. Add 3 to both sides to get 7 equals x. Well, unfortunately, they didn't ask us for x. We had to find BC and AD. So I got my choice. I think I'm just going to go down here because I got the space down here. Probably easier to do the top one because it's an adding instead of a subtraction. But it's your choice. 21 minus 3 is 18. So I know that AD is 18. Since BC and AD have to be the same, because opposite sides have to be congruent, I already know BC is also 18. I could plug it in if I want to, don't need to. If you do want to double check, again, it's got a built-in check, we do get 18. To get Z, it looks like Z is going to deal with these two angles. They're kind of big, but they do go with these two angles. And in a parallelogram, opposite angles are congruent. So that's another one of our parallelogram properties. So that means that angle B and angle D have to be congruent. So I can set those two equal to each other. So B is 2z plus 15. D is 3z minus 17. So we can subtract 2z on both sides. We can add 17 on both sides. And we get 32 for z. So we know z, in this case, z is in the table. So we can put 32 in the table. It didn't ask us to find the angles. Obviously, it could if it wanted to. But in this case, we just had to find z. So we did. We got 32. And so that's our values for all three of our options. All right, for 23, which choices are true for all squares? Now, I haven't done squares yet. That's what we're going to do in the week we get back from break. So the idea here is we have to remember how our quadrilaterals are all related. So you got your generic quadrilateral. There's nothing really special about it. It just has four sides. But remember, we can split this into a couple of special ones. So we did a lot of work with trapezoids. Trapezoids have one set of parallel lines. So none of those are just one set of parallel lines, so we know those are still all in play because squares don't really follow from trapezoids. We did the kite, which is no parallel lines, but two sets of congruent sides. Again, squares don't really follow from kites, so we're kind of ignore those as well. And the other special one we had was a parallelogram. For a parallelogram, instead of 0 sets or one set, it's got two sets of parallel lines. So if I check over here, I can pick everything that I want from a parallelogram because a square lives in the parallelogram family. So if something's true for a parallelogram, it has to be true for a square too. And in this case, we're actually not going to pick any of those because none of those have to be true for a parallelogram. That's a little disappointing. But that's okay, because from the parallelogram, remember we get two extra things. We get the rectangle. And a rectangle would be all the angles are the same. They all have to be 90 degrees. And we get the rhombus. And that's if we make all the sides the same. So if we look, we got to see if either of these are properties of either the rectangle or the rhombus. And this one is. Diagonals are perpendicular. That's a rhombus property. So we're going to pick that one because we know a square also has all sides are the same. Diagonals are congruent. This is actually a rectangle property. So we can pick that one too, because in a rectangle, the diagonals have to be congruent. So that's nice. So we got two of those. But we know if we put these two both together, that's how we get the square. And it turns out one of the properties of the square, that's its unique property, is that the diagonals will bisect the opposite angles. You'll get 45-degree angles if you draw in the diagonals. So we got to pick all of them because they're true for all of them. So that one works out. 24, most precise description for A, B, C, D. So again, we have to kind of use the same quadrilateral family that we did over here, just to kind of decide which one we want to pick. Definitely has four sides, so it's a quadrilateral. So if I can't figure anything else out, I'm going to pick that one. Doesn't really look like they got 90-degree angles, so I'm probably not going to pick the rectangle. But let's see what we can say. So if we look really carefully, it looks like we got two interesting looking triangles. What we're given angle B, well, ABD. So that's this one right here. And CBD are the same. We're also told ADB and CDB are the same. But we also have a shared side in the middle here. So BD and BD are the same. That's a reflexive. These ones up here are both given. Probably should have wrote that earlier, but that's okay. And so this means that if we look, we've got an angle, another angle on the side between it. It looks like we've got two congruent triangles, ADB and CDB, by angle side angle congruence, which means, this is kind of interesting, that AB has to be the same as two ends. Wait, did I get that right? ABD, CBD? Oh, not CDB, CBD. Always good to double check. Order matters. So ADB, CD. No, I had that right. That was good. I don't know why I'm changing it. All right. So either way, we got AB on the ends and CB on the ends. Those have to be the same by CP/CTC because they're in the same places. So since this is a 1 tick mark, that's also a 1 tick mark. All right, well, we got one more thing that we can see. AD, so the first and second, is the same as CD by CP/CTC. So first two. 1 tick mark and 1 tick mark, that means that all the sides are the same. Well, if I have all the sides are the same, that means I can go all the way to a rhombus. Now I might have a square, but square is not an option I can pick. So the most precise I can pick is going to be the rhombus because I can't pick a square. It could be a square, it doesn't look like one, but it could be. We don't know, but we do know that all the sides are the same, and that's what's true for a rhombus. So we're going to pick rhombus in that case. The last one is just a matching with all the theorems. So just kind of remember to study all the theorems. So just real quick, this is what all the theorems are. I'm not going to match them all up on screen. I can pull the theorems from anywhere. So any of the theorems that we've had in class, including the ones that we're going to do the week after break, are fair game. So just be sure to review all the theorems. There will be 5 of them. So just like there are 5 on the review, I'm going to pick 5 again for the actual midterm. So that's the number to expect for that one. All right, and that's going to be everything on the midterm review. So if this is helpful, good luck, and well, I'll see you in class if you do this before class. If you do this after class and before the midterm, I will see you for the midterm.